This lesson is a short introduction into the topic of radioactivity. In order to understand the four main types of radioactive emission, right, we need to understand the structure of the nucleus. So this video will be a short introduction into basic chemistry in case you're not teaching or not learning it, you're not learning it at IB level and you have little recollection of doing it in grade 10. So let me introduce the nucleus. And here it is. This is a traditional model, an old school model of the nucleus, because the electrons are in these weird kind of satellite orbital shapes around the nucleus. As you probably remember, and if not, don't worry, we will go on to this. Electrons don't look like this. Electrons do this. They live on discrete levels and shells. So luckily, right now, we're going to focus on the nucleus only. Right? The nucleus is where radioactive emissions come from. And we represent the nucleus using this kind of notation. This is a notation which represents the structure of the nucleus, which is made up from neutrons and protons. Now we express the number of neutrons and protons using this notation, placing the mass number, that's the total number of protons and neutrons, on the top, and the number of protons on the bottom. In physics, we don't use very often the terminology mass number. We use nucleon number. A nucleon is any particle that lives in the nucleus. And so therefore, it's neutrons and protons. Both of these are nucleons. Right? So where do we put the nucleon number? We put it on the top. This is a nucleon number. And then the proton number, in chemistry, it's called the atomic number, goes on the bottom. Now, why is the proton number so important? The number of protons dictate the element itself. If you change the number of protons, you change the element. You might be familiar with this object, I'd like to think so, and as you can see, this number here is the most important number because it tells you which element, right, goes where. The number that you see here is like the signature of the element. It tells you basically what element it is. So this is the proton number. If I was to change the proton number of carbon from 6 to 7, then I would be performing magic or alchemy, because I would be changing or transmuting, as it was often referred to, an element into another. By alchemy is that old reference of turning lead into gold. Simply changing the number of protons would allow you to do that. However, it's a very difficult thing to do. So, two basic ideas. Nucleon numbers, the number of protons and neutrons, go on the top, and the proton number goes on the bottom. Isotopes are an interesting aspect to elements, because although the number of protons cannot be changed, the number of neutrons can be different without actually changing the nature of the element itself. So if I commonly find carbon as having number of protons 6 and the number of neutrons 6, it's also possible to find carbon which has 5 neutrons. It doesn't mean that it stops being carbon, it still stays being carbon because the number of protons is still the same, right? But what we have here is an isotope, and its chemical properties, that means its ability to combine with other elements and to explode and things like that in a chemistry lab, is the same as for carbon-12. However, there might be some difference in its physics relationships, as in radioactivity. You might find that some isotopes are radioactive and others aren't. Okay, so two very important points. An isotope has the same number of protons but a different number of neutrons, right? And some isotopes of completely stable elements sometimes are radioactive. Okay, now those are the basics. what I want you to do is to practice the first set of questions that are on the assignment. Questions like this one, which asks you to basically label the number of protons and the number of neutrons for this kind of element. Also to draw simple diagrams showing you the structure of those atoms. I'll just give you a brief example. The number at the top here is the nucleon number, so that's telling you the number of protons and neutrons. This one's telling you the number of protons. And then lastly, which I didn't mention until now, is the number of electrons. The number of electrons is equal to the number of protons. So when we draw our atom, what we have here is 3 protons for lithium, 3 neutrons for lithium, and because they have 3 protons, we have 3 electrons as well. Electron shells, this is revision, but in case you don't remember, the electron arrangement is always 2 on the bottom shell, and any left over go on the second shell, up to a maximum of 8. Right, so 2 and then 8. This is not a question that you would get in a physics paper, but it's good to do a bit of revision there. Try doing lithium without looking at the answer, and then try all the questions which refer to students that haven't done chemistry.